this assessment asks us why tertiary amines like triethylamine and pyridine are often used as weak bases in nucleophilic acyl substitution reactions, but diethylamine or ethylamine as a secondary or primary amine are never used in this way. Well, I've shown on screen an example of a reaction where we might use triethylamine, and its purpose, we're not going to show the full mechanism, but the purpose of this is it's going to soak up the proton that forms in the process. So when this alcohol attacks, it's going to bring along its proton. This nitrogen, this amine, will grab that proton so that at the end of the reaction, we have this. Instead of having HCl floating around, we will have made this ammonium chloride. Well, what if we did this same reaction, but in the presence of a primary amine like ethylamine? Well, what would happen here is now we would have a competition set up where this alcohol and this amine can both be nucleophiles with the acid chloride. What's more nucleophilic? Nitrogen, being less electronegative, is much more willing to share its pair of electrons, and so that nitrogen could attack the carbonyl, and then eventually, we're not going to show again the full mechanism, but eventually you would end up having made an amide. So if we use a primary amine or a secondary amine, an amine that has that proton that can fall off, we're likely to end up with an amide as opposed to an ester. Now, one of the questions you might have is, well, doesn't this nitrogen have a lone pair that it can also add? And it does, but when it attacks, because it doesn't have a proton that can be removed, it would just get kicked back out. So in order for the amine to productively make an amide product, it must have at least one proton attached that can fall off in the process of the reaction. And so a tertiary amine or an amine like a base like pyridine without those protons to be removed really only serve the function as weak, so-called non-nucleophilic bases in acyl substitution reactions.